So this is the 2019 paper 1, question 9 here, and this one focuses around vectors and properties of vectors. So it's a three-parter. A has two parts and B is just a question all on its own. They're all relating to the two vectors u and v that you're given here. So first one, A part 1, wants an expression for u dot v. Now remember, to calculate this, what we do is we add the products of the corresponding elements of the vectors. So we take the two x components, multiply them, two y components, multiply them, two z components, multiply them, and we get our, our work. So first one, I take p bracket 2p plus 16. I'm then going to add on the product of the next components, which is negative 2 times negative 3. And I'm then going to add on the product of the third components, which is plus 4 times 6. Now for this question, that there is suffice. That's us got the mark that we're after. However, part 2 wants us to determine the values for p for where they're perpendicular. Now for this one, we have to use the fact that we know the dot product u dot v is equal to 0 in order for them to be perpendicular. So what I want is this expression I've got here equal to 0. So in order to do it, what I'm going to do is start simplifying it. So if I multiply out the brackets and calculate each of these corresponding terms, what I'm then able to say is therefore 2p squared plus 16p. I've then got negative 2 times negative 3, which is 6. I've then got 4 times 6, which is 24. So I can then say, right, so putting them all together gives me plus 30. That there equals 0. So now I've got to factorize. A quadratic, so we factorize to solve. Take out 2 as a common factor, and you get 2 bracket p squared plus 8p plus 15 equals 0. Factorize that into 2 brackets, and I get 2 bracket p plus 3, p plus 5 equal to 0. So what that then means is that p equals negative 3 and negative 5 for it to be perpendicular. So there's my two solutions that I've got there. You can tell you're going to get more than one solution by the fact that it uses the plural values rather than value, or doesn't put a condition on p that it has to follow. Now part B, determine the value for p for which u and v are parallel. Now remember, parallel, they have to have the same base direction vector. Well, if you look at the two vectors and we just compare the y and the z components, if I was to take out 2 as a common factor for this one here, I'd have negative 1 and 2. And if I was to take 3 out as a common factor here, I'd have negative 1 and 2. So what that means is they're both scales of the same base vector, which means that they can be perpendicular to each other if this x component is the same. Now if I was to take each element here and triple it, and each element here and double it, they'd be the equivalent to one another. So what I'm going to do is use that fact for the first part in order to solve it. So what I'm going to say is, based on that information, I know that 3p is equal to 2 bracket 2p plus 16. If they follow this, then what happens is I end up getting the value for p that I want. So open this bracket out, multiply it, and start to simplify and solve. I get 3p is equal to 4p plus 16, but 16 times 2, sorry, which is 32. So if I shift all the p's here and all the numbers here, what I'll end up getting is that p is equal to negative 32 for that one. So there you go. That's when we got the value for p for which u and v are parallel vectors. So there we go. We've answered all the parts of this one. Now, as I've said, part 1 is worth a single mark, which is just this. If you simplified it, you'd still get the mark for that, even if you just wrote this down, even if you simplified it wrong. Part 2, determine the values for which are perpendicular. So the first thing is you need to know the condition. So you need to know that u dot v is equal to 0. We then need to create an expression from it, i.e. 2 bracket p squared plus 8p plus 15 equals 0. We then have to factorize and get p, so the two values for p that we're after. For part B, it's worth 2 marks. First, for setting this up here. Second, for manipulating it and getting that p is equal to negative 32. So there you go, 6 marks in total for that, all relating to the properties of vectors and how they relate to one another.